Okay, so this is the second lesson for Quiz 4, and this lesson is on solving inequalities. So an inequality is very much like an equation, except that it doesn't use an equal sign. It uses a little symbol, a greater than or less than symbol. A lot of the times you call them alligators or Pac-Man symbols. And so here's an example. So if I write this, that got a 3 and an x, and I put this symbol in between, that means that x is less than 3 because it's on the small side of this little symbol, and on the large open side, the 3 is on that side, so that means that 3 is larger than whatever x is. So the way that you can remember this is that the alligator eats the larger number. So right now it's like eating the 3, and so that means that 3 is bigger because it's hungry, right? It wants to eat the big one. And so x could be any number less than 3. And so let's write that down. X could be any number less than 3. And so it's not like equations where we solve it and we say, okay, x equals 5, or x equals 7, or x equals 3. In this example, x could be 2.9, 2.8, 2.85, right? It could be anything in between as long as it's less than 3. And so to represent that x is less than or greater than a number, we use these symbols. And those symbols on a graph, we would use this circle. And I'm going to demonstrate this in just a second. Now, if we use this symbol with a line under it, or this symbol with a line under it, now it's either greater than, or less than, or equal to. That's what this extra little line means. It means that it could be equal to the number as well. So if I had added up here, if I said this, now x could be any number smaller than 3, or x could also be 3, because I've added this line. Okay, to represent that on a graph, we would have a circle, but we would shade it in. So that means that it's including that number. So an example of this would be to say graph the solution for, let's put that symbol. And so what we would do is we would just draw a number line. And we might say, here's -1, 0, 1, 2, 3. Maybe we'll extend this a little bit here. Put in a 4. Okay, so x has to be any number smaller than 3. And so I would put a circle around 3 like that, which means that we're not including 3 as a possible solution. But then I would shade or draw a thicker arrow this way and say, that arrow says that x should be anything that direction of 3. Now, if I added this line right here, then x could also be equal to 3, and so I would show that by shading in that circle. Okay? Now, if I rewrote this, x is less than or equal to 3, this means the same thing as this, because look, I flipped the alligator symbol, and so it's still on the small end of it. And so these two ways of writing that same inequality, those are equivalent methods. Okay, stop it there for 1 second. Okay, so I had to erase my board. Now we're going to look at how you actually solve an inequality. So it's just like solving equations. So for example, if I said solve, and then I gave you an inequality, and it was, let's say 5x is, let's say, less than 20. Okay? We solve this the same way that we solve equations. So we use PEMDAS backwards. We say, what's happening to x? It's being multiplied by 5. We need to divide by 5 on each side. And that makes 1x. So x is less than 20 divided by 5 is 4. And now we could represent the solution by graphing how we just did previously. Now, there is one exception to this. So if I said solve, and I gave you -8x is greater than 24. All right, so we would do the same thing. We say when x is being multiplied by -8, so we need to divide by -8 on each side. And so that makes a +1, x, which is just x. Now, when we divide by a negative, or when we multiply by a negative, only when we divide or multiply by a negative, we have to flip this alligator symbol. And so I'm going to make it go this direction now because I divided by a negative on each side, and the answer to this is negative 3. All right, and so to check this then, we could do the same thing. We could put a negative 3 back in for x, and we would say negative 8 times a negative 3 makes a positive 24. And now, of course, so let's write that out. Negative 8 times negative 3, and we're supposed to be greater than 24. So this is the check. Now, is it true that positive 24 is greater than 24? No, it's not. And so it actually didn't work, and here's why. We plugged in negative 3, but x can't be negative 3. It's not equal to. So we would actually have to plug in some number, any number, that is smaller or less than negative 3. And so maybe negative 4 would be okay, and we're checking that. That makes a positive 32, and that is, in fact, greater than positive 24. Now, if we hadn't have flipped this symbol, let's see what would have happened. If we had just kept it so that x was greater than negative 3, now when you plug a number that's greater than negative 3, like negative 2 is greater than negative 3, any positive number is greater than negative 3, well, if you go ahead and plug a positive number in for x, then you would have negative 8 times a positive number would give you a negative number. And a negative number is not greater than a positive number. And so this is the incorrect method. You must flip that alligator symbol when dividing or multiplying each side of an inequality by a negative number. Okay, and let's do one more example. And so second example is x over negative 2 is less than or equal to 3. And so take a second, pause the video, and see if you can work this problem out. Okay, so to work this problem out, we say what's happening to x? It's being divided by a negative 2, and so what we're going to want to do is multiply by a negative 2 on each side, and so that makes a positive 1, x, and so what we're left with is x, but we multiplied by a negative number, and so we have to flip this alligator symbol. And so now x is greater than or equal to 3 times negative 2 is negative 6. And now to check it, now in this instance we actually could choose negative 6 because x could be equal to negative 6. That's what that extra little line means. And so we would say, let's try negative 6. So if we go back to the original problem and say negative 6 divided by negative 2 is less than or equal to, and 3 was what was in the original problem, well that actually turns out to be a positive 3, and that is less than or equal to 3. It's equal to 3. And so that's a correct solution. And that's the end of lesson 2.